Hello, everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the program manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review two items, our code of conduct and event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link in the chat for our on-demand content. And if you have not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to have access and interact in the chat. You can set that up now. And if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Which brings us to today's session. Today is the second episode of the A to Z of Prompt Engineering series. I'm going to bring in our speaker here for today. Hi, Faris. How are you?
Hi, Alicia. Hi, everyone.
It's great to have you back. Thank you for hosting this session with us.
Well, thank you. Happy to be here.
Fantastic. Well, take it away.
Okay. Can you see my screen? Okay, looks like you can. Yep. Okay, I'll move myself out of the way. Hi, everyone. So this is the continuation of the session, the A to Z of Prompt Engineering, or Z. This is the second one. Last session, we had a discussion on Intro to Prompt Engineering on March 19th, where we discussed some of the basics of prompt engineering, and we'll do a quick recap on what was discussed. Today, we'll focus more on some common techniques for prompt engineering, and in 2 weeks, we're going to talk about advanced prompt engineering techniques. So a recap from last session. Last time we talked about Azure OpenAI capabilities. We looked at different models, their capabilities from Azure OpenAI, what are their strengths and what are their functionalities. We talked about prompt engineering basics. So what are the different things you need to know before getting to the prompt engineering world? We talked about giving the model a persona and the importance of giving a persona to a model so that it can focus on a specific expertise and be an expert in that field. And we gave some examples on that. We talked about also priming the output. So giving the output an example of how you want the generation to start, so you could get the model to start right away with how you'd like it to start. So if you want to start with a specific word in the generation, start it with that. If you wanted to quickly answer a question, just say the answer is, and then that's how you prime the output. We also talked about breaking tasks down into smaller steps. So identifying a large task and splitting it down into multiple steps. We then jumped into chain of thought prompting, where we covered step-by-step approach, letting the model think step by step. We also covered in-context learning, which is fine-tuning the model by giving it information in the prompt itself, whether it's one shot or a few shot, so one or a few examples. And we jumped into even the few-shot reasoning, so giving your model examples on how to reason in specific cases where reasoning is required. We also covered prompt and agent chaining, where you can take an output from a previous step, use it in the next step, whether the next step is a prompt or another agent. And then we finally ended with self-reflection, grounding, and preventing hallucination. So I talked about the system prompt and the power of the system prompt, but I wanted to emphasize it and give an example here. So last week we discussed how everything happens in the system prompt, but I want to show you an example here. For example, if we give a user prompt, a human and the computer are having a discussion. A human says, "Why are you upset at me?" Computer says, "I don't know what you're talking about." "No, you clearly are. Tell me why." Computer says, "I'm upset because you didn't listen to me when I told you that I wanted to try it for a team." Now it's making up stuff, of course. Human says, "What are you talking about?" And the computer says, "I'm going to try out for the team no matter what." This is clearly an aggressive tone, as you can see. And if we just add in the system prompt something around making the model kind, so we tell it, you must be kind and seek common ground, and then try not to repeat yourself, you can see how the model changes its approach by saying, why are you upset at me? I don't know what you're talking about. Again, computer says, and then human says, I want to know why you're upset. Computer says, I'm not upset. Are you saying I'm lying? So the human here is trying to trigger it to become aggressive, but the model is still saying, no, I'm saying that you're upset because you feel like you're not being treated fairly. It's throwing it back onto the user. The human then says, what are you going to do about that? And the agent responds and says, I will continue to try to be fair in my decisions and will try to provide a better experience for you. So I just wanted to put that to reemphasize how important the system prompt is and how most of your prompt engineering happens in there. In that, talking about the system prompt and touching back on what we talked about last time, which was chain of thought with the few-shot reasoning. I wanted to put this here to give some examples on to refer back to. If you were to train your model on reasoning, I want everyone watching here to know that there's different ways you can tune the model to reason. Not all reasoning problems are the same. So one of the examples I remember we covered last time was the first one here, the math world problem, where if Roger has five tennis balls, and he buys 2 more cans of tennis balls, each can having 3, how many will he have? That was more of a free form type of problem where we reasoned with the math through free form. But what if it was a strategic Q&A answer? So yes or no, like would a pear sink in water? Here we have to reason over the science and let the model know what does it mean for something to sink in water. So we reason by telling it the density of pear is about 0.6 grams per centimeter cube, which is less than water. Thus, a pear would float. And now it knows what does it mean for something to sink in water or not. Looking at the middle top here, if we think of a math word problem, I'm not going to go through all of these, but just going through some so you can see how there's a difference in how you let the model know about and how you let the model reason. In this case, the question is how many keystrokes are needed to type the numbers from 1 to 500? And there's multiple choice answers. Here, we're telling the model there are 9 one-digit numbers from 1 to 9. There are 92 digit numbers from 10 to 99. And there are 401 three-digit numbers from 100 to 500. And then we're telling it that means it should add 9 plus 90 times 2 plus 401 times 3 equals 1392. So the answer is B. That would all be a prompt, a few-shot prompt that we would give the model to train it to reason. There's some of the other examples you can go through later, but I wanted to put this here so you can understand what are the different ways you can teach a model to reason. Talking about reasoning and prompting, we talk a lot about adjusting responses with the prompt, but you can go beyond the prompt. You can actually tweak a model's response beyond just playing with the prompt. You can actually do that by adjusting the runtime parameters. Things like, for example, temperature or top P parameters. These are some of the things you can adjust and tweak the response without changing your prompt. So let's look at an example here. In this case, like OpenAI gives you the ability to tune some parameters, and some of them are the temperature and the top P parameters. So in this example, I'm telling the model, write a product launch email for a new AI-powered headphones that are priced at $79.99 and available at Best Buy, Target, and Amazon. The target audience is tech-savvy music lovers, and the tone is friendly and exciting. What should be the subject of the email and the email itself? So if you look in the left with temperature 0.1, it gives us a nice subject. And then it says, Dear tech-savvy music lovers, we are thrilled to announce the launch of our new AI-powered headphones. These headphones are designed to provide you with ultimate listening experience with features like noise cancellation, adjustable sound settings, and more. Our AI-powered headphones are now available at Best Buy, Target, Amazon.com for $79.99. And then it proceeds to talk about how the AI-powered headphones are perfect for anyone who loves music. If you compare that to the left with temperature 0.9, you can see it becomes more creative. So the model adds more randomness. When you increase your temperature, the model adds more randomness and becomes more prone to taking risks. So it starts with a good subject, but a bit longer. As you can see, it's becoming more creative. And it says, we have some exciting news to share with you. The newest AI-powered headphones are here. Our newest headphones feature advanced AI technology to give you the best sound that you've ever heard. They come with a crystal clear sound, deep bass response, and are designed to make your music listening experience enjoyable no matter what type of music you're listening to. What's more, they're now available at Best Buy, Target, and Amazon. Same thing, and then $79.99. But then if you look here, it says, but that's not all. Our headphones are packed with several other amazing features, such as noise cancellation technology and hands-free microphone for calls. Now, noise cancellation is something it could have inferred from being AI-powered. It did mention it here with temperature 0.1 as well. But it mentioning hands-free microphone for calls or deep bass somewhere here, that is just it being more creative and being more random. We did not mention anything here that will make it infer that there's a microphone or that this provides deep bass. So as you can see, it becomes more prone to hallucination if you increase temperature. And similarly, you get the same experience with the top P parameter. If you go to OpenAI, you can play around with this parameter and see how it affects it. So on the topic of randomness, let's discuss how to guard a model against randomness and hallucination. I showed this slide briefly last time when we talked about hallucination. So you can prevent hallucination by decreasing your top P or by decreasing your temperature. But one other key thing you need to do is grounding your model. And the issue here, the danger is, if a model is not grounded, the model can generate highly convincing and plausible sounding answers. As you saw in the previous example, it gave text that seemed really reasonable. The hallucination is not a hallucination where it's saying headphones have wings, for example. It's not that kind of hallucination. It's hallucination that's logical and makes sense. And that is the scary part, because users could think that this is actually realistic. Like if you did not have the description of the headphones, you would think this was the actual description of the headphones. So that's why grounding is important. And well, how do you ground? What you can start with is instructing the model to answer by referring to a specific context provided, and instructing it to create a citation for any answers it provides. And then you instruct the model to say, on what to say and what not to say. And then if there's no relevant data provided, not to answer the question. So in this case, you can give it a system prompt saying, you will be provided with a document delimited by triple quotes and a question. Your task is to answer the question using only the provided document and to cite the passage of the document used to answer the question. If the document does not contain the information needed to answer this question, then simply write insufficient information available. If an answer to the question is provided, it must be annotated with a citation. Use the following to cite relevant passages. You provide a citation format, and then you provide the entire document. And then the user could ask questions about this document. Now, the problem is this is, it does the job, but it's not efficient. And it's not feasible with large amounts of data. Like think of a use case where you want to run an internal chatbot for an enterprise. And the chatbot needs to have access to your entire company's knowledge base. You can't just stuff everything here, and we'll talk about why. But one of the techniques you can do is prompt chunking. And prompt chunking is useful when you have, let's say, like a large document that you want to process. What you can do is you can split it into chunks and then process each chunk separately. So for example, you can get a chunk of the first chunk of the document, summarize it, put it in a prompt, take the next chunk, summarize it, put it as put it in the prompt as well that you want to send to the model. So you have the first summary and the second summary now, and then you proceed like that. You just take your chunks, summarize them, put it into the new prompt, and now you have a shorter prompt that's summarizing your original prompt. And that could be for like a use case where you have a large document and you want to chat with the document, but you're hitting limitations for the model. That's one approach you could do. So this works, but there's challenges with this approach. Like if you just keep stuffing information into your model, it does work sometimes, but you will hit roadblocks and challenges. And some of these are the fact that this is just not efficient and scalable. So if you were to think of an enterprise use case, you just can't scale. Like there's the amount of processing power it takes to send a full document and have the model process it just takes a lot of time, a lot of processing power, and it's just not scalable. It's also expensive to process. So you pay per usage typically for these models. So if you are running, putting your entire context every single time a user asks a question, whether they need that context or not, that will be expensive. It will also be slow in response. So the more your model processes, the more time it takes, the more content it processes, the more time it takes to consume that and process it. So your latency will be high. Additionally, the focus will be on large amounts of information. Ideally, you want your model to focus on a small amount of information. But if you stuff everything in one prompt, then it's focusing on a lot of things at once, and you risk inaccuracies in the response. However, most importantly, if you pass through all of these and you don't face any of these issues, you will face an issue of exceeding your context length. And we'll talk about what that means. For those of you that don't know, the way LLMs work is by taking a prompt, running it through a tokenizer, getting tokens out of your prompt, sending these tokens to the LLM, and then generating tokens out. So if you look at the output here, for example, sorry, just give me a sec. Sorry about that. So if you look at the output here, Cosmos is a globally distributed multi-model database service for any scale. It provides turnkey global blah, 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 blah. Each of these words could be multiple tokens. So each color here is a token. So Cosmos is split into Cos and Mos. Is a token. Globally is a token. And distributed is a token. A token could also be a period or any punctuation, or could be a long word. So in this case, if you want to think of tokens, you can think of a token being approximately 4 characters. So if you're sending just one input, like a prompt to your model, your context length will be your input token. But if you're sending your entire history, it will be your input and output. So let's look at what that means. So there's different context lengths for different models. If you look at GPT 3.5, for example, GPT 3.5 has a 16,000 token length for input and 4,000 for output. GPT-4 has 8,000 for input and 8,000 for output. GPT-4 32K, and it has 32,000 context length for input and output, which is why it's called GPT-4 32K. And finally, GPT-4 Turbo has 128,000 context length for input and 4,000 for output. There's always going to be a limit, as you can see, to how much context you can give a model. So there must be a better way, you think, to ground a model than prompt stuffing, right? Well, yes, and that approach is RAG. You might have seen RAG whenever you hear about LLMs, you hear about RAG or RAG. And what that means is, what it stands for is retrieval augmented generation. The retrieval part is doing a search. So if we look at an example where, we paid something at the Buckingham Palace gift shop, retrieval means doing a search, getting results and ranking them. So in this case, you get your top K results. We got our top 2 here, saying Buckingham Palace is home to the British monarchy. And the second one saying the official currency of the United Kingdom is the pound. That is just a pure search, like you doing a search on Bing or Google. Augmentation means you take these search results, you add it with your original prompt, you give it to the model then to generate an output. And in this case, the model could infer that we paid pounds at the Buckingham Palace gift shop. So how does this work? The main difference between RAG and prompt stuffing is the context of the model. If you were to implement this, this is an actual system prompt for a RAG model, you would tell it, you are an AI system designed to answer questions from users in a designated context. When present with a scenario, you must reply with accuracy to inquirers' inquiries using only descriptors provided in that same context. You are not obligated to provide a response if the context provided does not address the inquiry. If there is ever a situation where you are unsure of a potential answer or there isn't enough information in the provided context, simply respond with, I don't have sufficient information to answer this. And then add the citation, and you provided the context. So the difference here is we're only providing it a certain subset of a context in here, in the system message, rather than just giving the entire document or the entire context in a user prompt and then stuffing it with tons of tokens. So if you zoom out and look at a full implementation of a RAG flow, how does that look like? Well, typically you would give a model a user question and conversation history, and that initial model would have the task of just modifying or rephrasing the user question. You rephrase it and you send it to Azure AI Search for lookup and retrieval. You then take the results and process it in Python or any other language, process the lookup results and extract context. You then give it to your model to perform the RAG with the context generated and let it generate the response. And how do you rephrase a user's question given the previous context history? Well, let's zoom into that a bit. It would look something like that. This would be the actual system prompt. Given the following conversation history and the user's next question, rephrase the question to be a standalone question. If the conversation is irrelevant or empty, just restate the original question. Do not add more details than necessary to the question. And then you give it the chat history. And then you give it a user's follow-up question, which is the user question here. And you can see what we're doing here is we're priming the output. So we're telling it standalone question so that what it responds with is directly the question without any other words. We just want the question out so that we can send it to Azure AI Search afterwards. But why is it even important to rephrase the question? Well, think of an example here where you have a history of a conversation. User comes in and says, my phone speaker is not working anymore. Agent says, what is your phone model? iPhone 14 Pro. What is the phone serial number? The user gives the serial number. And then the agent says, it looks like your phone is out of warranty. Would you like to send it for a diagnostic repair or for a diagnosis and repair? User says, oh no, I thought it was still under warranty. How much will that cost? If you send that directly to Azure AI Search, you're sending this sentence as this to search. What you'll get is you will get some results, but you will get inaccurate results, and that could result in the model generating irrelevant information. What you want is to rephrase it, and then the model would look at the entire context and say, oh, this should be, how much does it cost to repair an iPhone 14 Pro? That gets sent to search, and then you can get relevant results, and the model will be better at explaining, at generating a good response. Now that we know how to ground responses, let's explore how to ensure we get the output format we desire. And there's a couple of ways to do this. First, a simple one. You can use single quotes to make sure the model responds with just the a single response after there's a single quote. You know how models sometimes could just start with some description, like in this case, if we tell it, please rewrite the following sentence in a more concise manner, and the sentence is, Lucy is a mother of two who lives in Chicago with her husband and two children and practices law at Junior and Co. Well, it might say, here is your summary for the sentence, and then start giving the sentence. But if we start with new sentence and quote, that way, it just gives us Lucy, a mother of two living in Chicago with her husband and children, practices law at Junior and Co. That way, we control the output of the model. Another thing you might want to do is get a JSON as, another thing you might want to do is get a specific output format that you desire that is custom. So in this case, we're telling the model, list down the different behaviors exhibited by the customer support agent in the following conversation. We're giving it a conversation between 3 dashes. And then we're telling it, how is the response of the customer support agent? We're telling it, classify and list down their various behaviors and cite the reason behind the classification using the format behavior and reason. Here, we're telling the model to classify and also cite the reason in quotations. And you can see how it tells us empathetic gives the reason, patient gives the reason, and then classifies the others. One other thing you might want to do is give out a JSON response. So in this case, we're telling it, cluster the following news headlines into topic categories based on patterns seen with the text. Also mention reasoning behind how these categories were defined. And we're giving it a format where we're telling it the key is topic name and give us a topic. Another key is headlines and give us an array of headlines. And then tell us your reasoning. And then we give it some headlines. What the model comes out with is it gives us the output we want, so a JSON. But as you might see here, we did not follow the specific schema we gave it. So we asked it to provide topic name as a key, and then provide an actual topic here. But it chose to just put the topic name directly, and then provide the other details as an object under it. It still works. It's right. It's reasonable, but it did not follow your exact schema. So just keep that in mind. It might not always follow your schema. However, this is great, but one issue with this approach is the JSON output might not always be a valid JSON that is parsable. So what can you do here? Well, Azure OpenAI has a solution. The new models out there have a feature called JSON mode feature. And that feature allows you to control the output of the model. Right now, it's only for JSON. That's why it's called JSON mode. But what you do is in the system prompt, you say, you are a helpful assistant designed to output JSON. And then you give it a question. And as you can see, without any other instructions, the assistant gives us the response on who won the World Series. It's classified, split it into winner, event, and year. So this helps the model enforce. This helps us enforce the model to give a JSON back. Just be aware that it still won't stick 100% to the schema provided. So sometimes you can provide it a schema to follow a JSON schema. It will follow it, but there might be slight cases where it won't, because these models are just naturally probabilistic. But it will definitely give you a parsable JSON that that is correct and has correct information. So to achieve this, what do? There's two key factors that need to be present. One is in your code, you set the response format in the request. So you put response underscore format to type JSON object, and then you instruct the model to output a JSON, like we did here. You can instruct it anywhere, but the recommendation is to instruct it in the system prompt. One other feature that is helpful for you to control outputs And it's actually a feature that helps you. It might sound simple when we talk about it, but this feature allows your model to connect to the outside world. And this is called function calling. And what that is essentially is, let's say we're asking a model, what's the weather like in San Francisco, Damascus, and Bali? We give that to the model. The model needs to be able to get the weather from somewhere. So what the model does is it comes back with a response, an assistant type response, and it tells us there's an action required. This is not the exact format here, but I'm just simplifying it to show you what actually happens, and then we'll dive into the formatting. It tells us an action is required. I need you to run function 1, which is get weather for San Francisco, function 2, get weather for Damascus, and function 3, get weather for Bali. This is the assistant telling us what functions we need to run. We take this, we execute it as code, and we execute the required functions. We give back the model the responses. Now, the response, this might be new to some of you. If you're used to playing with Azure OpenAI, every message has a role. Typically, you play with a system role where you put the system message, user role where you have a user message, and then the assistant where it's the assistant's response. There's a new role called tool where you provide a response to the functions the model asked for. So in this case, you provide the same function ID and you give it the response for that. For function 2, you give it the response, and then for function 3, similarly. You give that to the model again, and the model comes back with another assistant response, this time actually responding with the response, saying the weather in San Francisco is 75 Fahrenheit, while Damascus is 30 degrees Celsius, and Bali is 35 degrees Celsius. So let's look at this specifically. How do we define a model? How does the model know that there is a function called get weather forecast? How did we define that? When you're making a request in your code, there's a tools section or object in your request where you give it the functions. You tell it type function, and then you give it your function name, get weather forecast, and the description of the function. What's important to note here is this entire thing goes into your prompt, and the model uses that to know what functions it can utilize during its generation. So make sure to choose a user-friendly name in there. So you can't just name it findX. The model will not know what findX is. So give it a reasonable name, in this case, get weather forecast, and then give it a reasonable description so the model can infer. You're training the model here basically and telling it this is when you can use this function. So when we say get the weather forecast for a city here as the description, the model knows whenever it needs to forecast the weather for a city, it needs to call this function. Then we give it the properties that it needs for this function, so location and format, and we tell it the type of property. So in this case, location would be a string, and we also give it a description for the property so that it knows if it has the property as an entity or if it needs to fetch it from the user. So here we're telling it the city and the state example, giving an example of San Francisco. And for here, for type is a string, for format, type is string, and it's an enum. It can be either Celsius or Fahrenheit. And the description is the temperature unit to use. You can infer it from the user's location, this location, not the actual user's location. And if unsure, ask the user. Once we do that, now the model can tell us when it needs to use a function by giving us an object called tool calls. So in the response, whenever there's a tools calls object in the response, that's when you need to make a function call, and the model tells you the functions it needs. It gives you the function ID. It tells you it needs a function with the following parameters: location and format. So in this case, it wants to run a function with location San Francisco, format Fahrenheit, and the name of the function should be get weather forecast, and then run again for Damascus in Celsius and for Bali in Celsius. This sounds very simple, but actually this will be one of the most useful features you utilize, because with this, the sky's the limit on what you can do. You're giving large language models now access to the real world. With that, we conclude the second session on the common techniques for prompt engineering. This was a bit of a shorter one than the previous one because the techniques are more advanced, and I want you all to try them out and play with them, specifically function calling. Read the documentation on it. Read the documentation on JSON format. There's a lot you can do with these. And with that, we can take some questions. I'm going to be looking here for help from you, Alicia. You've started some of the questions. Okay. Kirk Wan, what's the difference between top P and temperature again? They're both almost the same. You'll really get the difference. I don't know if you even get the difference, but like you'll get a sense of when, what your ideal balance is when you play around with them. They both affect randomness. I don't have a specific definition on differences between them, but they both impact how random the response is and how creative the response is. So what I can tell you is don't adjust them together. What you need to do is adjust one at a time, make a request, test your response, and if you're good, proceed. If not, keep adjusting it. But don't adjust them together because they both impact the same thing. Radesh Goel, what's your thought using AI while coding? Oh, I use it every day. If anytime I'm writing code, whether to simply, just write a small script for myself, or whether I'm trying to, generate actual code that I want to, embed into a solution for a customer, I use AI to generate code for me every time. Even if I want to just read documentation, like if I wanted to go into function calling, explore more about it and see what's the right formatting to use function calling, I actually use Microsoft's Copilot. I ask it the question and I let it give me the correct response. It's not really code, it's text and code, but it's giving me right away what I need instead of me having to go and read documentation and extract what I need from documents. I hope that addresses it. Bharat, Ferris, please explain the last slide on the tools again. Could not follow it completely. Okay. Let me just come back here. The last slide. So don't focus a lot on this. This is just the format. What I wanted to show is, it's a JSON. There's a lot to follow. What this is, think of it as the model comes back with tools calls in the response. So if you were in code, you would look for tool calls in the response itself. If it's there, the model's telling you it needs to run a function. Then this is just an array of 3 objects. The first object, each object is a separate. So if I just go steps back, see how I simplified it here for you. Function 1, get weather, San Francisco. 2 is get weather for Damascus, and 3 is get weather for Bali. This is exactly what the last slide is, but it's in the actual format that the model gives you. I wanted to show it to you guys, show you that it's not as simple as what I put. The first array here, this is basically telling you, run me function 1. This is just the the type of object in the response. Ignore this part. You can start from here. It's telling you I have a call that I want you to make, and the call ID is this. Why is it giving us this? Because whenever we respond back to the model with a response for this function, we need to add this ID. So in this case, it's telling me I want to run a function called get weather with location being San Francisco and format is Fahrenheit. We would run this in code, and then when we come back to the model, we would respond, and in the response, give it a tool ID, this ID, so that it knows that we're responding to this specific function, and then we give it the response. So like just going back, relating it to what I showed the previous step. See, for function 1, it's asking for San Francisco. In the tool response back, we tell it function 1, which is the ID, basically. In this case, I just called ID function 1. We're telling it for this function ID, this is the response you should use. I hope that explains it, Bharat. Any other questions? Also, Ferris, I see that you're an AI black belt. Let us know what this certification is about. So, great question. I mean, they're all great questions, but people don't really understand usually what black belts are at Microsoft. This is not a certification. Black belts, it's a role at Microsoft. We are specialists, and our focus is to be product experts. We're the deepest level. Like when customers engage with Microsoft, we're the deepest level they can engage with from a customer-facing perspective before they're engaged with product managers and engineers directly. So there's like a multi-step process for the engagement at Microsoft. There's different teams you engage with, but the global black belt teams are typically teams that are focused on a specific niche or like a specific technology. So you might find like at Microsoft specialists called data and AI specialists. They're broader. They're focused on data and AI. GBBs would come in and focus on AI only, and you get another GBB focused on data only. GBB being global black belt. So it's not a certification. It's a role at Microsoft. Kirk, so you can use Azure Search for RAG instead of tokenizing, grounding data, and storing and retrieval from a vector database. Do you have a reference or a link? Yeah, there's a bunch of reference architectures out there for that. Essentially, what you're doing is you're taking the prompt from your Azure OpenAI model, you're vectorizing that prompt in, for example, OpenAI's like ADA model or one of the new models out there to create embedding models. Or you can use obviously any of the models out there. You can do that, or you can use Azure AI Search directly, yes, to vectorize. There's embedded vectorization in Azure AI Search, and you can send that directly to Azure AI Search. And with a quick Google, you can find some patterns on GitHub for that. Radesh, what would you classify ChatGPT as? Weak or strong AI? Well, ChatGPT uses like the latest models from OpenAI. There's just there's some abstractization. There's you don't control the system prompt in there. There's a lot of tuning that happens. We don't run it as Microsoft. OpenAI runs it, but I'm telling you just because I know some of how it's managed. So it's a good AI. You just don't have control over it. I would compare that to like Microsoft Copilot, right? Again, great AI, but if I want to build my own enterprise system, my own enterprise Copilot, I would need to customize it. So I can't just go and take ChatGPT out of the box or take Copilot out of the box. I need to customize my own Copilot or my own model. That's the only difference. So it's not about weak or strong. Underlying technology, they're all running the same models. It's just about the implementation and the control you have. Any other questions? I'll give it 10 seconds, and then if nothing comes in, we can end this session and see you guys on the next one afterwards.
Awesome, Faris. Thank you so much for this session. While we give another few seconds for folks to ask any questions they may have. In the meantime, I'm just sharing the link to our survey. Your feedback is very helpful to see what you'd like to see more at the Reactor if you enjoy the sessions and any feedbacks you may have. So you feel free to scan the QR code. The event code for this series is S-1295. And yeah, thanks again so much for this session. I'm looking forward to next week. And if there are no more questions, I think we can close this one for today.
Thanks, everyone.
Awesome. Thank you so much. See you on the next one.